Hi everyone, and welcome to our video of using SOHCAHTOA with inverse trig compositions. All right, so in these problems, the main thing is just to remember that inverse trig gives us angles, and then afterwards we're going to set up our SOHCAHTOA. So this part in number one, so it says find the exact value of each expression. Number one, it says cosine inverse of 5/8 is in the inner part of the function. So what we do is we say, well, we know that that is equal to an angle. So we'll just use theta. And then we can say, well, let's use this property where we can rewrite. So our rewrite inverse property to regular trig would mean that cosine of that angle should be 5/8. And now we can use SOHCAHTOA with this portion. So we've got our angle theta, and then we've got adjacent would be 5, so there's the adjacent side, and then the 8 is the hypotenuse. Okay, and then so it looks like we need to find the opposite side. Okay, so our opposite side, we can set up down here. We've got Pythagorean's theorem, so 5 squared plus the opposite side squared would equal 8 squared. And then we'll just do our order of operations. So 25 plus opposite side squared is equal to 64. Let's minus the 25 on both sides. Okay, so when we minus 25 on both sides, I should have shown that. Okay, so this is the same as 39. Okay, so 39. And then now we can square root it. Now, I like to do plus minus, but on this problem, we're just going to choose the positive because we have a physical right triangle. Here's one thing we do have to think about though sometimes on this. On this one, not too big of a deal, but remember this 5/8 is an x coordinate. Remember cosine inverse of something puts you in the top half of the unit circle, while an x coordinate that's positive would be in quadrant 1. Okay, so that means we should keep everything positive. So I'm just going to mark that right up above. That is in quadrant 1. Whatever that angle is quadrant 1. And notice we're not solving for the angle. So if you were following my videos in the order, exact order that they're given, like these previous problems, we were finding the actual angle. This time we're not actually finding the angle. So we're just setting up a triangle to help us along the way, because after this, we say, well, sine of theta. So we said that this whole thing is theta right here in this equation. So we have sine of theta is left over once we change it. So we do all this right triangle work to get this information so that we could solve for sine of theta. So sine of theta, now we can still use SOHCAHTOA, opposite over hypotenuse. So square root of 39 over 8. There we are. Okay, now let's take a look at this number 2. So it's pretty much the same thing, where we're gonna, let's mark this in purple right now and say, oh, that sine of inverse of negative 1/3 is an angle. And then we can instantly rewrite it using our inverse trig property up here. So we'll say, oh, that sine of that angle, sine of theta, is negative 1/3. Okay, and let's use blue again, where we could say, well, let's figure out what this is. So remember that sine inverse puts us between, so I'm just bolding it out, negative pi halves and pi halves. So again, if we had to find that actual angle, I mean, we could plug it into a calculator, but we're assuming we can't use a calculator on a problem like this because of the exact value. So we just have to break it down to what inverse trig does. This is a y coordinate, and it's negative. Well, a negative y coordinate in this range would be in quadrant 4 somewhere. Okay, so that's saying this is a quadrant 4 angle. Okay, so that means I do have to worry about the sign for our final answer. Okay, so we'll come back to that, but let's continue with our right triangle. So now that I have sine of theta, equaling negative 1/3. Well, again, we can use our SOHCAHTOA. We have opposite would be 1, hypotenuse would be 3. Again, I don't care about the negative right now because I already have it marked up above as quadrant 4. So in my right triangle, I just keep them positive. And then our adjacent is what's missing. So we have our hypotenuse and opposite, and then now we can use our Pythagorean theorem again. So adjacent squared plus the opposite side squared equals the hypotenuse squared. Let's use our order of operations. 1 squared is 1. Let's subtract that over right now. So we would have 8, and then square rooting. Again, for good habit, I would say put plus minus, but we're going to choose the positive. Also, the square root of 8 does simplify into the square root of 4 times the square root of 2. Square root of 4 we can do, so that means it's 2 square root 2. Okay, so our adjacent side is 2 square root 2. All right, and then now let's go back to the original statement and change that purple box into theta. So again, we're saying that whole thing is just an angle. We're using our generic letter for angle, theta. So secant of theta is what we want. And now again, it's back to this triangle with SOHCAHTOA. Well, for secant of theta, I would first get cosine of theta. Again, with this triangle, I would have adjacent, so 2 square root 2 over hypotenuse 3. And then now I'm saying, don't forget, we're in quadrant 4. Well, cosine in quadrant 4 would stay positive. Okay, so that is a positive number. Okay, so that means all I have to do now for my final answer for the secant of theta is to flip it. So 3 over 2 square root 2. And then chances are they would want us to rationalize. So multiply both top and bottom by square root 2. And we get 3 square root 2 over, that's just 2 right there. So 2 times 2 is 4. So 3 square root 2 over 4. Okay, so that's it. So when you see a composition with trig functions, it's mostly just do a SOHCAHTOA problem. Okay, so don't let them freak out. It's the largest part is SOHCAHTOA. Okay, so thanks for watching. If you have questions, please let me know.